The topic of this video is subtraction by addition. We will develop an algorithm that does just that. An algorithm is a step-by-step procedure that produces a certain result. In this case, we want the difference of two numbers. Before we can develop our algorithm, we have to define certain things. In our base 10 numeration, there are 10 basic numbers. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have these 10 numbers, and we can use one or more of these 10 numbers to write any other number. For example, if I want to write 15 minus 7, I would use 1, 5, and 7 one time each. The basic numbers have two numbers that have special properties. They are 0 and 1. The special property of 0 that we're going to have to use to develop our algorithm, if I add 0 to a number, I get the same number. 0 plus 5 is 5. The special property of 1 that we'll want to use later is if I multiply a number by 1, I get the same number. 8 times 1 is 8. No other number in the basic numbers have special properties except those two. In order to define what the 9's complement of a number is, I have to find the pairs of numbers in the basic numbers that add up to 9. So if I add that 9 to that 0, I get a 9. If I add that 8 to that 1, I get a 9. If I add that 7 to the 2, I get a 9. If I add 6 to 3, I get a 9. I add 5 to 4, I get a 9. So there's 5 pairs of basic numbers that add up to 9. Each number in the pair is the 9's complement of the other. The 9's complement of 9 is 0. 9's complement of 0 is 9. 9's complement of 8 is 1. 9's complement of 1 is 8. 9's complement of 7 is 2. 9's complement of 2 is 7. 9's complement of 6 is 3. 9's complement of 3 is 6. And the last one, 9's complement of 5 is 4. 9's complement of 4 is 5. The basic numbers, of course, have only whole numbers. So those are the 5 pairs. And we can refer to this, or if we can do it mentally, that's fine too. If we say what number added to 7 gives you 9, if you can think of that mentally, yeah, you put 2. Or you may have to refer to the 9's complement table. Okay. In subtraction, the number being subtracted from, 15 in this case, is called the minuend. The number I am subtracting, 7 in this case, is called the subtrahend. The result we get from this operation called subtraction is called the difference. So 15 minus 7 is going to equal 8. 8 is the difference. Minuend minus subtrahend equals the difference. The first subtraction I will do by subtraction. I will add the numbers in the minuend, 1 plus 5, that's a 6, and write 6 minus 6 plus 15. 6 minus 6 is a 0, and when I add that to 15, I get 15. I will take the 9's complement of the subtrahend, 7 in this case, which is a 2, and write minus 7 minus 2 plus 2. Minus 2 plus 2 is a 0. And when I add that to minus 7, I get minus 7. So this difference, 15 minus 7, will remain the same. Alright, my next operation, from 15 I'm going to subtract minus 6, I get plus 9. I'm going to bring that 6 down. 6 plus 9 is 15. So this is another way of writing 15. From minus 7 I'm going to subtract minus 2. When I do that I get minus 9. Then I'll bring this 2 down. Well, if I add plus 2 to minus 9 I get minus 7. So this is another way of writing minus 7. Why did I do that? Why did I add the numbers in the minuend to get a 6 and the 9's complement of the Septuagint to get a 2? Why did I use that for my zeros? Because I get this cancellation. 9 minus 9 is 0. So all I have to do to get my difference is add 6 plus 2. So that's equal to 8. So how many operations did I do when I did subtraction by subtraction? I did a subtraction here, one here, one here. That's 3 subtractions. And then I had to do one addition. So I did 4 operations to do subtraction by subtraction. Now we'll state our algorithm. The algorithm for subtraction by addition is, I will add the numbers in the minuend, 1 and 5. I get a 6. I will take the 9's complement of the Septuagint, which is 2, and add it to the 6. 6 plus 2 is equal to 8. So the algorithm for subtraction by addition, I did only one operation versus 4 for subtraction by subtraction. So on the basis of one subtraction problem, the algorithm appears to be accurate. 15 minus 7 is equal to 8. We get the correct difference. It appears to be easier because I only did one operation versus 4. And it appears that we're not concerned at all with the minuend. I mean, all we're going to do is add 1 to a number. That is the easiest addition there is. It hardly qualifies as an operation. We are mainly concerned with this Septuagint. So we're going to find the 9's complement, and we're always going to ask the same question. What number added to the Septuagint equals 9? In this case, 2. We will always ask the same question using this algorithm. What number added to the Septuagint equals 9? And when we find it, we can do subtraction by addition. We will try our algorithm on several other problems to check its accuracy.